draw the derivative of that graph. That's what's going to happen. Yeah. If you want to work on your desk and like you want to take a picture of your desk, I won't get mad at you for using your phone.
Yeah.
I mean, as long as that's what you're using it for. You can just make that through zero is probably the best way. Yeah. Well, if you can take a picture of it.
He didn't write the graph, but he wrote the title.
Did I put a title every time? There was one, I think it was like last year, 2 years ago. I didn't really used to. And then one girl yelled at me every single time I didn't put one.
So she didn't know what you were doing.
So I get so mad that I put it on.
That sounds.
It doesn't, that's not just like this.
Yeah. Maybe she had so many notes that she took like so many classes that she couldn't keep on track. She didn't know what it was.
Is it devices and not drawings?
Okay, so there's a few different ways to think about this, and I'm going to try to talk through different thought processes as I'm going. So let's just say this was like point A, so this one we don't have to worry about whether you went through the axis or not. A, B, C, D, E. Two of those points don't even matter, but I just wanted to have them so basically so you can know if they don't matter. So what does the derivative represent? Increasing and decreasing, or slope, right? The derivative represents the slope. So if the slope of the original graph is positive, the derivative graph should be fill in the blank, above or below the axis. Above. If the derivative of this graph is negative, or the slope of this graph is negative, since the derivative represents the slope, then we should be below the axis. So positive slope here means above the axis on the derivative. Write that down. Positive slope on f of x means above x-axis on x prime. And that's obviously the opposite, right? Negative slope on f of x means below x-axis. So the first thing I did, well, so the first thing I do is look at the two spots, or any, it could be different on each graph, but on this graph, there's two spots where I know exactly what the slope is, or the x values of those two spots. B and D, and what is the slope of both those spots? Here. So you're thinking about like the surfboard guy. So he's flat there, he's flat there. So I know the derivative graph has to be zero at those two spots because the derivative represents the slope of the original graph. And from there, it kind of splits my graph into sections. It's almost like that number line we did. So my I just look at this part, is the original graph, does the original graph have a positive or negative slope? Positive. And if the original graph has a positive slope, my derivative graph should be above or below the axis. Above. But also think about two other things. Is the slope getting bigger or smaller as I read it left to right? It's getting smaller. So it's the steepest here, right? Which means the y values of my derivative should be the biggest here. And then it gets flatter. So it's going to go like, don't draw it yet, but it's going to look like this. There's a couple ways I know that it curves like that. One is that I know it has to be 0 here. This doesn't tell me why it curves. It doesn't know why it goes down. The slope here, like if I draw a vertical line down, isn't that slope at that spot bigger than, say, the slope at this spot? Like this surfboard is steeper than this surfboard, so this y value better be bigger than this y value. The second thing I want you to think about is, so this works every year and I don't ever understand how many wiggles are in the original graph? 2. Everybody says 2, and I don't know what a wiggle is. You don't know what a wiggle is. We all just said 2. So, right. There will be always one less, not always. It's like a sine or cosine graph. How many wiggles are in a sine or cosine graph? Infinite. So that doesn't apply. It doesn't apply in every situation. But in most graphs, your derivative will have one less wiggle. And here's why. What's the power of this graph? This is x to the 1. Third. Well, when you take a derivative, don't you knock down the power? So now do we go to the second? And how many wiggles are in a parabola? 1. Again, I don't know what a wiggle is, neither do you, but we all just said 1. So your derivative needs to be a parabola, basically. That's what I'm saying. So if you have 2 wiggles here, you gotta have 1 wiggle in your derivative. So I'm thinking in my head, okay, 1 wiggle is a parabola. I'm starting to draw that parabola. And the question just basically becomes, is it gonna go down to up or up to down? Okay, so now we'll look at this middle piece. In this middle piece, is the slope of that graph positive or negative? Negative. So my derivative needs to be below the axis. And where is the slope the steepest? Like the biggest negative? At point C, what kind of point is that? That's the point of inflection. That is going to be the relative min. So we're going to make this parabola. And the bottom of it is going to be its wiggle there. And I know that the slope needs to be below, is negative, so we got to be below the axis. But we also have to come back up, because what's the slope at this time? 0. And the lowest point is going to match up with the point of inflection. Because that is the most negative that the slope was during that little section. And then over here is your slope positive or negative. Positive, and is it getting bigger or getting smaller? Bigger. So my y values of the derivative need to be positive and getting bigger. And that dotted line would be like your f prime of x. I'm going to go a level below that line. I'm going to take the second derivative. So I'm taking the derivative of the dotted. So how many wiggles are in the dotted line? 1. So if I go a level down, I want to have a 0 wiggle graph. So what's a 0 wiggle graph look like? A line. I still know what a wiggle is, neither do you, but we all just said line. So the line, basically it's going to either go up or down. And like where does it cross through? That's the question we have to ask. So I'm going to start with the same process I did last time. There's one spot where I know exactly what the slope of the second derivative is. Where is that? C. And what's the slope of this at that spot? 0. So I'm going to put a dot right there. Prior to that, so to the left of that, and remember I'm looking at the dotted line here, is the slope positive or negative? Negative. So should my y values of the derivative be positive or negative? ask it this way. Is it positive or negative? Negative. And is it negative and getting bigger or negative and getting smaller? Negative. It's getting bigger. Because isn't it getting closer to zero? And if negative numbers are getting closer to zero, negative and getting less negative is a good way to say it too. So my y values of the derivative need to be negative and getting less negative. So they're going to start down here. And how many wiggles do I have? Zero. So it's just going to be a line. I'm going to do this to like differentiate it. And then if I go to the right of C, is my slope of the dotted, positive or negative? Positive. Positive and getting bigger or positive and getting smaller? Positive and getting bigger. So I need my y values to be positive and getting bigger, and I got to keep in mind that I can't have a wiggle, so it's going to be a line. And again, this makes sense. So this was an x to the third situation. So when we take the derivative, we get an x squared situation. When we take the derivative of the squared, we lose a power, so we get an x situation. But if you just have an x, what kind of graph is it? It's a line. Questions up till here? I'm going to go another level down. What has less wiggles than a diagonal line? A horizontal line. This gets a little shaky. Like people kind of lose the wiggles in this part. But look at it this way. If this was like y equals 3x, what would be the derivative of y equals 3x? 3. And what kind of line would y equals 3 be? Horizontal. So the next level down from here would be, whatever this slope is this slope positive or negative? Positive and getting bigger or positive and getting smaller? It's positive and staying the same, isn't it? This slope here is positive and it's the same positive the whole time, right? So my derivative needs to be positive and the same the whole time, which would look something like this. This would be f triple prime. That's called jerk. You can call people a triple derivative. That's like a nerdy calculus thing. Quit being a triple derivative.
I think it's easier to think about it if you think about it as like acceleration because it would, well, okay, if you thought, well, okay, never mind. So that double pump would be acceleration.
Yeah, I'll get there in a second. So then, we got one more level to go before they start being all the same every time. This would be like y equals k, right? Like y equals 3, like we just said. What's the derivative of y equals 3? Y equals 0. So the level down from a horizontal line up here, basically, like, just, I don't know if the wiggles got to lose their meaning, but the derivative of this would just be across that 0. Now I'm not even going to draw it because that's kind of messy as it is. Wow, that's not a horizontal line.
It's going slowly down.
Yeah.
That looks like you're trying to draw a line in second grade.
So, if we get into physics, like Maya was saying, this original one is position. What's the derivative of position? Velocity. What's the derivative of velocity? Acceleration. What's the derivative of acceleration? Is jerk. I don't know what happens after that.
And then it's like, it's out of acceleration or something. It's weird. It's like bounce and then it gets out. What's jerk?
Jerk is a change in acceleration.
Yeah.
So, like they say, when you're driving a car, jerk is what makes you spill your drink. That helps you.
So it's the person that
I want you to try to draw that derivative. I kind of went from introduction to hard here. We'll see how it goes. Let's skip a few levels along the way. Let's try it. How many wiggles?
1, 2, 3,
4. So if this one had, if this had 2, it's like min to max. For 1, 2, 3, 4. A wiggle's like a turnaround. If I were to define it, like how many times does the graph turn around? That's 4, right? 1, 2, 3, 4. This is tough. I skipped ahead. Fast forward here. Start with where you know the derivative is 0. So you got point there, point there, point there, point there. One of the reasons I want to use markers. I think I might have fast forwarded a little. I'll give you another second, then we'll try. That's okay. I mean, we'll get there in a second. Yeah, just do the first one. You'll never be asked to do all of that. I was just trying to like give you an overview of how it is. So here's something that might help too. Let me go through this method. Some people like to go through and write ink, D, ink, D, ink. And then if the original is increasing, where do you know the derivative has to be? Above the axis. And if the derivative is, the original is decreasing, your derivative has to be below the axis. So you're almost setting up like a number line. And then again, I know the zeros because I know that those spots are 0. And I know I'm going to have to be like making some curves. So I got to be above the axis over here, below the axis there, ink in this part, so above the axis, but I got to come back to 0. D here, so below the axis, and I got to come back to 0. And ink there. And if you're going to get really technical about it, this point should line up with what? The point of inflection. This point should line up with the point of inflection. This min should line up with the point of inflection. But I'm not too worried about that at this point. Does that help with the derivative? Put the ink and deke there? That's what I'm thinking. It's just like writing it down. Question on what I did on this. I know we're going to do a ton more, but questions what I did on this one. Try that. Again, start with what you know. Zeros. Anything else you write on there? Is that a laugh or is that me saying inappropriate things? So I'm going to put the slope is 0 here, so I'm going to go there. Slope is 0 here, so we're going the axis. Slope is 0 there, so we're going the axis. We're decreasing before that first dot, we're increasing after, then we go back to decreasing, then we go back to increasing. How many wiggles does this original graph have? The one I'm looking at? 3. So my derivative, so this would be an x to the 4. So when I take the derivative, it'll be an x to the third, and an x to the third graphs have how many wiggles? 2. So it's going to have 2 wiggles. So basically, it's either going to be this or this. And that's your job is just kind of to figure out which one. And since my original graph is, let me ask these questions again. Is the original graph increasing or decreasing? Is the slope here? The slope there positive or negative? Negative. Is it negative and getting bigger or negative and getting smaller? It's negative and getting bigger. Don't just get to put your own answers to my questions. It's negative and getting bigger. So our derivative graph better be negative but getting bigger. Or less negative. And then here, slope positive or negative? Positive. In this part, is your slope getting bigger or smaller? That's concave up, isn't it? So your slope's getting bigger. In this part, is your slope getting bigger or smaller? So our slope needs to be positive and getting bigger up to the point of inflection, and then smaller. And they very rarely care about like being as specific as the point of inflection. Just trying to help you understand more what's going on. So there is our derivative, or is our slope positive or negative? Negative. There, negative and getting bigger, and negative and getting more negative. Negative and getting more negative, right? There, negative and getting less negative. So I need to be negative and getting more negative up until the point of inflection, so around there. And then negative and getting less negative. And then here, everything's just up. So that would be your derivative. How many I know? Nice. Questions on what I did to get it? Go a level down from that. Take out double prime. It's easier.
Yeah. It's just the one.
How many you still have that look on your face? Did you get mine? You said you looked like you didn't know what was going on. Is that still the case?
No, I got it.
Okay.
Do you want us to find the next group?
No, that's good.
No, say that whole sentence back.
Okay. So we have currently a 2 wiggle graph, which is an x to the third situation. We take the derivative, it'll be an x squared situation, which is a 1 wiggle graph. parabola. So we just gotta decide basically is it a U or an upside down U. So I know the zeros are there and there, which also match up with the points of inflection if I drew it like perfectly. And then prior to that, remember we're looking at the dotted one. The graph is increasing, so the slope is positive but getting less positive, right? So our y values of that derivative need to be positive but getting less positive, keeping in mind that it's going to be a parabola. And then in this piece here, the slope is negative. And the slope is negative and getting more negative up until there. And then it's negative and getting less negative. So that's your turnaround spot. And then it just everything goes up positive and getting more positive. So this is BF double. How many of that? Thanks. Questions on that? Try this one. This is the only graph, the only equation where this occurs. Here's a clue. This is y equals e to the x. Graph the derivative. That's a gigantic clue. I should never regret getting that.
I think I got.
Really should have given it.
Yeah, that.
But make sure, see if you understand why.
I've also got questions.
Yes.
I mean, how can you figure it out?
Okay.
Because, like, if the change will apply, would it like shift?
No.
It would stay the same if the change will apply?
I mean, would the derivative still be the same?
Yeah.
It would not. So
So
it
it would
would
be a
shift.
different spot,
Yeah,
right? It would be like same x. No, it would be same like value.
It would make it like faster up or slower up. Okay, so
That's a hard
I kind of gave it away, but what's the derivative of e to the x? E to the x. But I'll make sure you understand why. If you look at the y values here, is it true that they'll never be zero, right? Yeah. And they are slightly positive and getting bigger as you go. That's what's happening with the y values, right? But isn't that also exactly what's happening with the slope? Your slope will never be zero, never be flat. It starts off very slightly positive. The surfboard's like barely pointing up, and it gets more positive as you go. So this is the only graph where that occurs. Try this one. We're gonna graph y equals sine of x. So you're gonna help me do it. What's the sine of negative pi?
You're honestly
30.
30? What's the sine of negative pi? No.
Zero.
Zero.
Yeah.
Negative pi is negative 180, so like from your perspective, that's over there. But sine's the y value, right? Zero.
Yeah.
You can't celebrate, you said 30. Negative pi over 2, where's that? Straight down, what's the y value straight down? 1, 0, positive 1.
He went through that fast.
There's kind of a pattern. Graph the derivative.
Sure.
What's your, I skipped your question, Joe. What you want to ask?
It was like if the e to the n.
Oh, that's
e to the 2x
Okay.
squared. It would be like a different number of a derivative. Like the graph would be different.
Yeah.
Yeah.
So the wiggles thing doesn't really work here because sine has like an infinite number of wiggles. But it kind of, I mean, you can kind of see it. It just doesn't fit. Like, let's subtract one part. I mean, you can kind of see it, but it's not. So the derivative would have infinite Don't graph negative cosine.
Noah's a cheater. I know it was.
Oh wait, yeah, don't get, yeah. Go ahead and graph negative cosine. See how that works. It's cosine. Yeah. Okay, so if I'm graphing this, this is not proportional at all. Now I feel shame about that. This should be higher. Alright, so the two spots I know, the derivative is 0, be right there and right there. To the left of this, the slope is positive or negative? Negative and increasing or decreasing? Negative and increasing. I guess you kind of got to know. It starts like this. Because you don't, yeah, I don't really have a reason for that. The slope here is -1. And then in this middle, or this second section, the slope is positive or negative? Positive and increasing or decreasing? Increasing. And we know it's going to be 1, because what's the biggest this side could ever be?
1.
Not 30, right? 1. And then in this section, slope is positive or negative? Positive and decreasing, and I got to decrease to get back to this slope of 0. And then in this section, slope is positive or negative? Negative and increasing or decreasing? Negative and decreasing. So it's got to be negative and getting more negative, and it's going to like end up.
That's
negative
just
1.
cosine.
Yeah, and this is well, yeah, because what's the derivative sign?
Cosine.
Derivative sign.
And then if we do another derivative, it's negative sine x.
If you do a derivative after that, what do you get?
Negative cosine x.
Go one more, what do you get?
Sine x.
Sine, then we just start over.
Oh my goodness.
Alright, we get here. It works. Smart remark or smart idea?
Wait, when's this one?
Can we not? We'll do 8 Christmas.
What day is Christmas?
No, what day is today?
So some of these have asymptotes and a couple other little twists, but it's multiple choice. And that's what he wants to be also. So you might not be able to like exactly figure out what's going on, but use your like okay, it should be increasing, decreasing. Use that stuff to match up with your best option. And some of them have backwards too. So like I gave you a graph and said which one. Here's the derivative. Which one was the original? So this is not like exactly what we just did, but we still use these tools to do these. I'll obviously answer any questions tomorrow. Answer on that. Is that why you guys are all gonna be like weird faces? Sorry. I'm sick, self-conscious. Like, what am I saying? That's fine.
Okay, with the option
Wiggles.
Obviously, I have this here.
Let's use the proper terminology.
You already know.